Okay, hello again. This is the chapter on chemical calculations. Some IG teachers call it stoichiometry or mole calculations. So this is what we're talking about. Okay, first of all, to start with, we need to know what is a mole. A mole is an amount in chemistry, and it is the relative atomic mass in grams. So the mass in grams is the mole. So if sodium has a molecular atomic mass of 23, then 23 grams of sodium is 1 mole. Okay, so mole is the relative atomic mass in grams. Now, the relative atomic mass that you have in the periodic table, which is the mass number in the periodic table, the big number in the periodic table, this is actually an average of the mass number of the different isotopes in the ratio of their occurrence. So if we have different isotopes for the element, the average of the masses of all of these different isotopes relative to how much of them do we have, the relative abundance or their occurrence, then that is the relative atomic mass. Now, if I want to get the molecular mass, that means for a molecule, the molecular mass is also referred to as mass of 1 mole. It is actually the sum of the atomic masses of the atoms in the molecule. So, if he asks you to calculate the mass of 1 mole or the molecular mass of something, so the first thing that we need to do is write the formula. So I want the molecular mass or mass of 1 mole of magnesium phosphate. How do I write the formula of magnesium phosphate? What is phosphate? Phosphate is PO4 and its valency is 3. So we write the symbol of each one, put the valency of one under the other. The valency of magnesium is 2 and the valency of phosphate is 3. So it is Mg3PO4 twice. Okay, so that is the formula of magnesium phosphate, and from that I can get the mass of 1 mole. To get the mass of 1 mole, we add the masses, the mass number of each of them, total mass numbers of all of the atoms. So, for example, you look at the periodic table, what is the mass number of magnesium? It's 24. How many magnesiums do I have in that formula? I have 3 magnesiums, so it is 24 times 3, plus the next one. The next one is phosphorus. Mass number of phosphorus is 31. Now, how many phosphorus do we have? Can you see that we have 2 phosphorus? The number that is at the bottom applies to whatever is immediately before it. For example, that 4 applies only to oxygen, doesn't apply to phosphorus. But whatever is outside the bracket applies to everything inside the bracket. So actually I have 2 phosphorus atoms, so 31 times 2, plus oxygen, the mass number is 16, times how many oxygens do I have? I have 2 times 4, and that is 8. Okay, so the total of all of that is the molecular mass or the mass of 1 mole. Okay, let's try another one, barium nitrate. How do I write barium nitrate? First of all, please remember that in your periodic table, you have something called barium and you have something called bromine and something else actually called boron, and there is beryllium. So make sure that you're looking at the right one. You're looking for barium. Now barium is Ba and it is in group 2, so that means it has a valency of 2. How do I write nitrate? Nitrate is NO3. What is the valency of nitrate? 1. So barium, valency 2, I put the 2 under the nitrate. Nitrate, valency 1, I don't write anything under the barium. So that's the formula of barium nitrate. Now, how do we calculate the molecular mass of that? I look at the periodic table and I take the big number, the mass number. So the mass number of barium is 137. How many bariums do I have? There is no number written below Ba. That means that I have only 1 of them. Plus nitrogen, mass number is 14. How many nitrogens do I have? I have 2 nitrogens. Can you see that? Plus oxygen is 16 times. How many? You multiply these numbers. 2 times 3. 2 times 3 is 6. So the total is 261. Okay, so now we know how to calculate molecular mass. The next thing you may be asked to calculate is empirical formula and molecular formula. Now, first of all, you should know the definition of each one. The empirical formula is the formula showing the simplest ratio between the elements, while the molecular formula is the formula showing the actual ratios. So molecular formula may be the same as the empirical, or it may be multiples of it, twice the empirical, 3 times the empirical, and so on. Okay, so let's try an example. A compound has 18.2% potassium, 59.4% iodine, and the rest is oxygen, and he's asking to determine its empirical formula. Now, how do I do this? I put the symbols of each one. So we have potassium and iodine and oxygen. He says I have 18.2% potassium, 59.4% iodine, and the rest is oxygen. How do I get the rest? These are percentages, so the rest would be the rest of 100. So 18.2 plus 59.4, and you subtract that from 100, you find that the oxygen is 22.4%. Okay, so now we have the percentages of each one. Now what are we going to do? We're going to go through 2 main steps. Simple, straightforward. The first thing you do is divide by the mass of each of them, the atomic mass. So what is the atomic mass from the periodic table for each of them? Potassium is 39, iodine is 127, and oxygen is 60. You multiply each of the percentages by the mass number of each element. Now that means I end up with these numbers. Now I want to simplify these because these are supposed to be a sort of ratio, so I need to simplify it. In order to simplify it, my next step is divide by the smallest. What do I mean by that? I look at the numbers, 0.47, 0.47, 1.4. Which one is the smallest? 0.47, I divide all through by 0.47. I end up with 1 to 1 to 3. Now, please don't stop here. You haven't written the empirical formula. Remember that the empirical formula is the actual formula with its ratios. If the ratio is 1, you don't write any number. So it is KiO3. That is your answer. Okay, let's try another one. A sample of a hydrocarbon with mass 7.2 grams contained 6 grams of carbon. First of all, here he's not talking about percentages. He's talking about masses, but you're going to handle it in exactly the same way. Okay, he gives me hydrocarbon. Do you remember what's a hydrocarbon? A hydrocarbon is something that has hydrogen and carbon. Now he's saying the hydrocarbon total has a mass of 7.2, and the amount of carbon is 6. So how much hydrogen? It's the rest of the 7.2, right? So these are the masses of each. So remember that these could be masses or they could be percentages. We're going to work with them in exactly the same way. What was the first thing that we did? Divide by the atomic mass. So mass of carbon is 12, mass number of hydrogen is 1. I end up with 0.5 and 1.2. So the first step, divide by atomic mass. Now what was the second step? We said divide by the smallest. Which of these is the smallest? 0.5, so I divide through by 0.5. I end up with this kind of ratio. Now I have a problem because these ratios are supposed to be whole numbers. Now in the previous question it came out as a whole number because it is something 0.0 or something 0.9, then you round it up to a whole number. But if it is something 0.4, I need to multiply through by something that will change the 2.4 to a whole number. So try multiplying by 2. Does it give a whole number? No. Try multiplying by 3. It doesn't give a whole number. Try multiplying by 4. You will find that you will need to multiply by 5 in order to end up with whole numbers. And remember, you multiply all through by 5. So my ratio now is 5 to 12, and that means that my empirical formula is C5H12. Do we understand how we got that? Okay. Let's try this question. A student prepared crystals of hydrated magnesium sulfate. After drying the crystals, the student weighs them and then heats them until they reach a constant mass. Remember that we said hydrated salts are salts that have water in their crystals. So this is magnesium sulfate with some water in the crystals, and I don't know how much water. I'm doing this experiment in order to determine how much water. So we're trying to find out what is X in magnesium sulfate, X water. Okay, these are the students' results. The mass of the dry crystals before heating is 17.2. So that means that all of it with the water was 17.2. Now, the mass of crystals after heating to a constant mass, heating to a constant mass means he heats until he gets rid of all the water. That gives you 8.3 grams. So that must be the mass of the magnesium sulfate alone without the water. Now, use these results to find the value of X in the formula of magnesium sulfate, X water. Now, what do? It is just like we're getting a ratio, or we're getting an empirical formula. So you're trying to get the ratio between magnesium sulfate and H2O. So in this case, the mass of magnesium sulfate alone was the mass after you heated and removed all the water. So that is 8.3 grams. Now, what was the mass of the water? That is the rest of the 17.2, because 17.2 was the crystals containing the water. So that means I had 8.9 grams of water. Now I deal with it as if it is a empirical formula. Magnesium sulfate is 8.3, water is 8.9. I divide each of them by the masses. So the mass of magnesium sulfate he already gives me is 120. The mass of water is 18. If you calculate it, it's oxygen plus hydrogen plus whatever. Now that gives me a certain number. I divide by the smallest, and I found that I have 1 magnesium sulfate to how much water? To 7 water. That means that X is 7. Following? Okay, so that has to do with the empirical formula, and you can do more examples in the chapterized questions. The other calculations are calculation to obtain number of moles. We said that the molecular mass in grams is 1 mole. So if I have, for example, let's say sodium, sodium has a mass number of 23. That means 23 grams of sodium is 1 mole. Now, what if I don't have 23 grams? What if I have 46 grams, for example? Then 46 grams would be 2 moles. 3 times of that will be 3 moles, and so on. So that means that the number of moles is the mass divided by the molecular mass. Now, that is an equation you have to memorize. Number of moles is mass over molecular mass, and the mass should be in grams. But what if we're not trying to get number of moles? What if we're trying to get something else? So number of moles is mass over molecular mass, and remember that molecular mass, we will be denoting it by MR from now on, okay? But what if I want to get the mass? Now, if I want to get the mass, then from that equation, can you work with the equation? So find the value of M. The value of M will be number of moles times the molecular mass. What if I want molecular mass? How do I get molecular mass? You should realize that molecular mass is mass over the number of moles. Okay? Okay. Then this is the first equation we use when he gives me mass in grams. So if he gives me mass in grams and he's trying to get number of moles, then I use that first equation. But sometimes we don't have mass in grams. Sometimes he talks about gases and he gives volume of a gas. Now, if I want the number of moles from volume of a gas, it is the volume over 24. 24 is something constant. This is because 1 mole of a gas has a volume of 24. So if I have a certain volume, then I divide by 24 to get the number of moles. Remember that this equation works using a volume in decimeter cubed. You understand decimeter cubed? Okay. What if he gives it to me in centimeter cubed? You should realize that to change centimeter cubed to decimeter cubed, you divide by 1,000. So number of moles is volume over 24. Now, how do I get volume from that equation? Volume is number of moles times 24. Okay? And remember, the volume in decimeter cubed, if he gives it to me in centimeter cubed, then I should divide by 1,000 before I put it into the equation. Okay. Number of moles. So far we said mass. If he gives me mass, I use the first equation. If he's talking about volume of a gas, I use the second equation. But sometimes we're not talking about gas, we're not talking about masses, we're talking about solutions. So he's saying I have sodium hydroxide solution, hydrochloric acid solution. For solutions, usually he gives concentration and volume. So you should realize that number of moles in that case is concentration times volume. Again, the volume has to be in decimeter cubed. So number of moles is concentration times volume. Okay, what if I want something else? What if I want concentration, for example? Then you should realize that from that equation, concentration is number of moles over volume, or volume is number of moles over concentration. So let's try a question. Calculate the number of moles of sulfuric acid in 20 centimeter cubed of a 1 mole per decimeter cubed solution. Okay, things in centimeter cubed are volume. So volume is in centimeter cubed or decimeter cubed. Concentration is in mole per decimeter cubed. So this mole per decimeter cubed is the concentration. So it's giving me concentration, it's giving me volume. So which equation am I using? I'm using the equation that says number of moles is concentration times volume. So remember that you choose the equation that you're going to use depending on what he gives you in the question. So here he's given me concentration and volume. I don't have mass, for example, to say mass of a molecular mass. I don't have volume of a gas, but I have concentration and volume of solutions. Then I use number of moles as concentration times volume. Remember, the volume that you put into the equation has to be in decimeter cubed. So if he gives it to me in centimeter cubed, I have to divide by 1,000. So once I do that, I get 0.02 mole of sulfuric acid. Do you understand that? Okay. Another question. What is the concentration in mole per decimeter cubed of a solution containing 7.84 grams of phosphoric acid in 400 centimeter cubed? What is this? Let's think about it one by one. He's asking for what? He's asking for concentration. I have a separate equation that says number of moles is concentration times volume. But then he's giving me mass. So if I have mass and he wants concentration, so I need to get the number of moles first and then use it in the other equation. So number of moles is mass over molecular mass. I change the mass that he gives me into number of moles. So 7.84 grams over the molecular mass of what we're talking about, which is phosphoric acid. Do you remember how to calculate molecular mass? The mass of hydrogen, and I have how many hydrogens? The mass of hydrogen is what? Mass of hydrogen is 1, but I have 3 of them, so actually the total is 3. The mass of phosphorus, 31, and I have only 1 of it. The mass of oxygen, 16, and I have 4 of them. Add it all up, that is the molecular mass of phosphoric acid. Once you do this, we end up with 0.08 mole. But he doesn't want mole, he wants concentration. So I look at the equation that relates moles to concentration. So concentration is number of moles over volume. The number of moles that I got over the volume that he's talking about, again, I cannot put it in form of centimeter cubed. I have to divide by 1,000 first before I put it into the equation, so that's why it's 0.4. I end up with a concentration of 0.2, and that means my answer is C. Following? Okay. Now, there is actually a fourth equation now for number of moles, because we already said that 1 mole of any gas occupies a volume of 24 decimeter cubed, and that is why we said number of moles is volume over 24. But Avogadro's law is talking about the number of molecules. Are we following? So, number of moles is concentration times volume, or volume over 24, or mass over molecular mass. That's number of moles. And 1 mole of a gas occupies 24 decimeter cubed, so that's the volume of 1 mole of a gas. But if I have 1 mole of something, let's say 1 mole of a gas, what is the number of molecules in it? Or 1 mole of a substance in any case. So 1 mole of a substance contains 6.02 times 10 to the 23 6.3 molecules. Remember that the word molecule is a very small substance. A molecule is made up of one atom or two atoms or something like that. So molecules are very, very small. So 1 mole of something will have a very huge number of molecules. Avogadro's constant decided that 1 mole of a substance has 6.02 times 10 to the 23 molecules. Okay, so that means that if he wants the number of moles from the number of molecules, he says I have a certain number of molecules. What is the number of moles? I divide by the 6.02 times 10 to 23. Or if I want number of molecules, then I multiply the number of moles by 6.02 times 10 to the 23. So that number is called Avogadro constant. Okay, another kind of calculation would be from equations. So he will give me a certain equation and he will say I started with something. Okay, how much of something else will I get, or how much of something else will I need to react it with? So let us try an example. This is an equation between sodium carbonate and hydrochloric acid. We wrote the balanced chemical equation. You already know how to write balanced equations, right? Okay, so this is sodium carbonate plus hydrochloric acid to give sodium chloride, water, and carbon dioxide. And the question is, what is the volume of HCl needed to react with 5.3 grams of sodium carbonate if the concentration of HCl is 2 mole per decimeter cubed? Let's take this one by one. He's asking for what? He's asking for volume. What does he give? He gives 5.3 grams of sodium carbonate. Now, whatever he gives me, the first thing I should do is get the number of moles of that thing. Because in order to get something for HCl, I can relate it to whatever he gives information about. So here he's given information about sodium carbonate. Okay, what does this balanced equation actually mean? You should realize that the balanced equation shows the ratios of moles when they react. So that equation that we have there is no number in front of sodium carbonate, and that means the number is 1. So that means 1 mole of sodium carbonate will react with how many moles of HCl? With 2. So if I have 1 of sodium carbonate, it will react with 2 of HCl, and that means that the number of moles of HCl will always be twice sodium carbonate. Now, to give what? To give 2 moles of sodium chloride. So the number of moles of sodium chloride will always be twice that of sodium carbonate, but it will be the same as the number of moles of HCl. Plus H2O, so that means that the number of moles of H2O is the same as the number of moles of sodium carbonate. Can you see what I'm saying? Carbon dioxide, 1 mole of sodium carbonate gives 1 mole of carbon dioxide. So the number of moles of carbon dioxide would be the same as the number of moles of sodium carbonate. So if I know the number of moles of one of them, sodium carbonate, I can relate it from the equation in order to find out how much I should get from the other ones. So what does he tell me? He says I have 5.3 grams of sodium carbonate. So the first thing I need to do is get the number of moles of sodium carbonate. Now what does he give me? He gives me 5.3 grams. Then I need to use the equation that involves grams. Number of moles is mass over molecular mass. The mass is 5.3 as he gives me. And then I sit down and calculate the molecular mass of sodium carbonate. Sodium is 23 and I have 2 of them. Plus carbon, which is 12 and I have only 1 of it, plus oxygen, which is 16 and I have 3 of them. Calculate all of this, it comes out to be 0.05 mole of sodium carbonate. So that means that I'm starting with 0.05 mole of sodium carbonate. Now let's look at the equation again. How many moles of HCl will I need? We said from the equation, the number of moles of HCl must be twice that of sodium carbonate. So if I'm starting with 0.05 of sodium carbonate, the number of moles of HCl will be twice of that. Number of moles of sodium chloride will be twice of that. Water is the same, so number of moles of water will be the same, 0.05, and number of moles of CO2 would be the same, which is 0.05. That we get from the relation of the equation. So what is he asking about? He's asking about HCl. Now, In order to get volume of HCl, I need number of moles of HCl. So if I have 0.05 mole of sodium carbonate, what would be the number of moles of HCl? We said it should be twice. So actually now I know the number of moles of HCl. Now I can get volume. Which equation involves volume of solution? We said number of moles is concentration times volume. So the volume is number of moles over concentration. Now number of moles is 0.1, and he tells me in the question that the concentration is 2, and that means I have 0.05. 0.05 what? We said the volume from the equation is in decimeter. Okay, so what comes out from that equation is in decimeter cubed. But what if he's asking for the volume in centimeter cubed? How do we change decimeter cubed to centimeter cubed? Multiply by 1000. Okay? Okay, so this is a typical question. 2.5 grams of calcium carbonate were heated to give calcium oxide and carbon dioxide. The first part of the question says write the balanced chemical equation. I'm starting with calcium carbonate. You should remember that this is how we write calcium carbonate, because a valency of calcium is 2 and valency of carbonate is 2. So we don't put any numbers under them. Also calcium oxide, valency of calcium is 2 and valency of oxygen is 2. So that's how we write it. So this is the equation. Balanced? Yes, it's balanced. Okay. Now the first question says determine the mass of calcium oxide. He doesn't give me any information about calcium oxide, but he gives me information about what? About calcium carbonate. So I need to use that information to get number of moles of calcium carbonate. Then I can get number of moles of calcium oxide. Then I can determine the mass. Let's go through that. So he says I have 2.5 grams of calcium carbonate. So number of moles of calcium carbonate is, which equation am I using? The one that involves mass. Mass over molecular mass. The mass is 2.5, and I calculate the molecular mass of calcium carbonate. You know how to calculate that now. So I end up with 0.025 mole of calcium carbonate. Okay, but he doesn't want calcium carbonate. He's asking about what? He's asking about calcium oxide. So I look at the equation and I relate this number of moles. Now, what does the equation tell me? The equation says if I have 1 mole of calcium carbonate, I will have the same number of moles in calcium oxide. So the number of moles of calcium oxide should be the same as that of calcium carbonate. So that's 0.025 mole. Now, how do I get mass of calcium oxide from the number of moles? You should realize that we said number of moles is mass over molecular mass. So the mass is number of moles times mR. So I find that, and remember that here the number of moles is 0.025. And the MR is the MR of what? We're talking about calcium oxide. So you're trying to get the molecular mass of calcium oxide, and that gives you 1.4 grams. So that's the mass of calcium oxide. Now, the other part of the question says determine the volume of carbon dioxide gas. I will do basically the same thing. I already know the number of moles of calcium carbonate, which is 0.025 mole. I relate from the equation what would be the number of moles of carbon dioxide. The equation says number of moles of calcium carbonate is the same as that of carbon dioxide. So that is the number of moles of carbon dioxide. Now, how do I get the volume? We said the volume of a gas is from number of moles is volume over 24. So volume would be number of moles times 24. The volume that comes out is in decimeter cubed, multiplied by 1000 if we need it in centimeter cubed. Okay? Let's try another question. 9.8 grams of potassium chlorate. Now remember, we haven't talked about chlorate and you don't know what is chlorate, but in that case he will give you the formula. So if he's talking about something other than what we have talked about, he gives you the formula. So 9.8 grams of potassium chlorate was heated to give potassium chloride and oxygen. The first thing he's asking for is write the balanced chemical equation for the reaction. So I'm starting with the potassium chlorate, and it gives me potassium chloride. Remember that potassium valency 1 or chlorine valency 1. Oxygen is diatomic, so you have to put 2 under the oxygen, and then you balance. Okay? So how do we balance? I have one potassium, one chlorine, one chlorine. Now the oxygens are the ones that are not balanced. So if I have 3 on one end and the other 2 on the other end, then I can put 3 and 2. Then in that case, both of them are 6 oxygens. But that means that now I have 2 KCl, so I need 2 KCl. Okay, balanced. Okay, now what is he asking for? Determine the mass of potassium chloride. Now, he doesn't give me anything about potassium chloride, but he's talking about potassium chlorate. So from the 9.8 grams of potassium chlorate, the first thing I need to do is determine the number of moles of the potassium chlorate. Number of moles, he gives me mass, so I'm going to use mass over molecular mass. Calculate the molecular mass of potassium chlorate. Remember that when we're calculating molecular mass, we're calculating molecular mass of the formula. I don't multiply by that 2 that we added for balancing. We don't take into account the balancing when we are calculating molecular mass. So here I'm calculating molecular mass of KClO3, not the 2 that we added for balancing. So I get 0.08 mole of potassium chlorate. Okay, what is he asking about? He's asking about potassium chloride. So I go back to the equation and I take a look at the relationship between them. Now the equation says if I have 2 moles of potassium chlorate, it gives 2 moles of KCl. That means that the number of moles of KCl is the same as potassium chlorate, right? If this is 2, this is 2. If this is 0.08, the other one also is 0.08. So the number of moles of KCl is 0.08 mole. Now what is he asking for? Mass. We know that mass is number of moles times mR. We multiply the number of moles that we have times the mR of what we're talking about now, the KCl. And that comes out to be 5.96 grams of KCl. So that means that if I start with 9.8 grams of the potassium chlorate, I will end up with 5.96 grams of potassium chloride. Okay, what else is he asking for? Determine the volume of oxygen. Oxygen is a gas. How do we get volume of a gas? Using number of moles is volume over 24. So if we say number of moles is volume over 24, that means the volume is the number of moles times 24. So the first thing I need to determine is what is the number of moles of oxygen. I look at the equation. The equation says if I have 2 moles of KClO3, I will end up with 3 moles of oxygen. How many moles of KClO3 do I actually have? I have 0.08. So if I have 0.08, how much do I end up with? So the number of moles of oxygen is the 0.08 times 3 divided by 2. So that comes out to be 0.12 mole. Do we understand that? 2 moles give 3 moles, so 0.08 will give how much? Okay? Then I use this number of moles to get the volume. He wants volume of a gas. Volume of a gas is number of moles times 24. So it is the 0.12 times 24. And I get that to be 2.88 decimeter cubed. What comes out from the equation is in decimeter cubed. You want to change it to centimeter cubed, you multiply by 1,000. Okay, another thing that you could be asked to calculate is to calculate the percent purity. What do we mean by percent purity? The percent purity is the mass of a pure substance divided by the mass of the impure substance times 100. What does that mean? So if I say that I have, for example, calcium carbonate solid. I have 5 grams of calcium carbonate, but I'm telling you that actually this calcium carbonate is not pure. So in the 5 grams, I have only 4 grams of calcium carbonate plus other impurities. Are you following? Then, so if I say 4 grams of the calcium carbonate and the rest is impurity, then the percent purity will be the 4 over the total mass of the substance times 100. So let's try a question. It says an excess of hydrochloric acid was added to 1.23 grams of impure barium carbonate. Once he says mass of impure, that means I actually don't know what is the mass of barium carbonate. Because if it is impure, that means not all the 1.23 grams is barium carbonate. Some of it is barium carbonate and some of it is impurity. So I'm just going to put the 1.23 grams on the side for now. the volume of carbon dioxide collected at room temperature and pressure. RTP means room temperature and pressure, and he just tells you room temperature and pressure in order to be able to use the equation that says number of moles is volume over 24, because the number of moles is volume over 24 is used only if we're talking about room temperature and pressure. Okay, so anyway, he's giving me a volume of carbon dioxide is 0.12 decimeter cubed. So that's the information that he gives me. Where is the carbon dioxide? I write the equation, of course. This is barium carbonate plus hydrochloric acid. This gives barium chloride plus carbon dioxide plus water, and I balance. So that is the balanced equation. And what is he telling me? He's saying the carbon dioxide, can you see where the carbon dioxide is? Was 0.12 decimeter cubed. And then he's asking about the purity of barium carbonate. So I'm going to use this information about carbon dioxide to get the number of moles of carbon dioxide and then relate it to the number of moles of barium carbonate in order to determine what is the actual mass of barium carbonate present. Are you following? So he gives me certain information. The information is about carbon dioxide. I use it to get number of moles of carbon dioxide. Number of moles is volume over 24, so I find that I get 0.005 moles of carbon dioxide. The equation says 1 barium carbonate gives 1 carbon dioxide. So if I have a certain number of moles of the carbon dioxide, they will actually be the same as the number of moles of barium carbonate. Now, what do I want? In order to get percent purity, I need to get the mass, the actual mass of the barium carbonate in the impure substance. So the mass is what? How do we get mass? Mass is number of moles times MR. So the number of moles that I calculated times the MR of barium carbonate I calculated, and I find that I have 0.985 grams of barium carbonate. That means that out of the 1.23 grams that he's talking about at the top of the equation, of the question, I have only 0.985 grams of actual pure substance. So the percent purity is the mass of the pure substance, 0.985, that's the one that we calculated, over the total mass of the impure substance times 100. So I find that the percent purity of this sample of barium carbonate is only about 80%. Okay? Okay, another thing that you will be required to calculate is percent yield. Now, percent yield has to do with, okay, he's trying to prepare something and he got, for example, 10 grams, but he was actually supposed to get about 12 grams. Because when we do an experiment, sometimes we lose, or usually we lose some of the solid or some of the crystals as we move along in the experiment. So as I'm doing the experiment, I lose some in filtration, I lose some in crystallization. So what I actually get in the experiment is usually less than what I should get. So what I actually get in the experiment is called the actual yield. What I should get is the theoretical yield that I calculate from the equation. For example, all of these equations that we've been talking about, we said we're supposed to get a certain mass of something. So that is the theoretical yield. So remember that percent yield is the yield that is actually obtained in the experiment when he says I did the experiment and I got a certain mass, over the theoretical yield, which is what we calculate that he should get, times 100. Okay, let's try again. He says 4.8 grams of hydrogen reacted with excess nitrogen to give 12.8 grams of ammonia. Calculate the percent yield of ammonia. So he's saying that he started with 4.8 grams of hydrogen. He's trying to make ammonia. What he actually got in the experiment was 12.8 grams. But I need to calculate what he should have gotten. What is the yield that he should get? And the word yield means mass, if you're not familiar with it. Okay? So the 4.8 grams of hydrogen, I use it to get number of moles of hydrogen. How do I get number of moles? Mass over molecular mass. Remember that we relate from the equations, we relate number of moles or we relate volumes of gases. We don't relate masses. I don't say I have 4.8 grams of hydrogen, so how much ammonia do I have directly? No, I need to relate it through moles. Okay, so number of moles of hydrogen is the mass over molecular mass, 4.8 over molecular mass of hydrogen, and remember that hydrogen is H2, so that means the molecular mass is 2, so I end up with 2.4 moles of hydrogen. Now what is he asking about? Ammonia. So I look at the equation, try to relate from the equation how many moles of ammonia am I supposed to get. Well, the equation says 3 moles of hydrogen will give 2 moles of ammonia. So the 2.4 will give how much? So the 2.4 moles times 2 over 3, that gives me 1.6 moles of ammonia. So I'm supposed to get 1.6 moles of ammonia. What is the mass of that? So the mass of ammonia, number of moles times molecular mass, is 27.2. So that means that he's supposed to get 27.2 grams from this reaction. But what did he actually get? He got only 12.8. So what is the percent yield? What he actually got, 12.8, over what he should have gotten, times 100. So we find that he got only 47% of his yield. Okay, the other kind of calculation is limiting reactants. Now, when do we talk about limiting reactants? We talk about limiting reactants if he's giving me information about both reactants. So if I have a reaction and he gives me information about both reactants, I need to determine which one I will use to relate to the product. So in the previous questions, he gave me information about only one. He said, for example, mass of barium carbonate or mass of calcium carbonate, or one reactant, and I use it to determine the rest. But here he's given me, for example, information about nitrogen and hydrogen. Now, which one am I going to relate in order to get the ammonia? I need to determine which one is a limiting reagent. Limiting reagents means I need to calculate the number of moles of each one as he tells me, and then look at the relationship in the equation and determine which one was too much and which one was not too much. So the one that is not excess, we call it limiting. Okay, let's try one by one. So he's saying I have 50 grams of nitrogen. So I get the number of moles of nitrogen, mass over molecular mass, and that comes out to be 1.79 mole. He says I have 40 grams of hydrogen. Get the number of moles of hydrogen. Remember that if he gives me 40 grams, I use the equation that talks about mass. I don't say this is a gas or something. We use the equation number of moles is volume over 24 only if he's talking about volume. Whenever he's talking about mass of something, mass of anything, solid or liquid or gas, we use number of moles is mass over molecular mass. So that comes out to be 20 mole. Now, I try to relate it. The equation says what? The equation says that the number of moles of hydrogen should be 3 times the number of moles of nitrogen. Are you sure? Are you seeing this? So the equation says if I have 1 mole of nitrogen, I react it with 3 moles of hydrogen. That means number of moles of hydrogen should be 3 times. So let us look at how many moles of nitrogen did he say I have. We calculated that we have number of moles is let's say 1.79 or 1.8 mole. So how many moles of hydrogen was I supposed to get? I was supposed to use actually 3 times of that. Now what is 3 times that number? That's about 2. 2 times 3 is about 6. So obviously, when he says that he puts 20 mole of hydrogen, that is way too much than what we need. So hydrogen is in excess. Do we understand how we determine which one is excess? Now, we determine that hydrogen is too much. It's excess. So I ignore it. I don't use it to relate to ammonia because not all of it was used. So when we determine that something is excess, the other reagent is now called limiting. So if hydrogen is excess, then the nitrogen is limiting, and it is the limiting that I use to relate to anything else in the equation. So now when I'm trying to get something, he's saying what? Calculate the number of grams of ammonia. Now if I want to get the mass of ammonia, I have to relate it to the nitrogen, not to the hydrogen, because the hydrogen was too much. So I relate it to the number of moles of nitrogen. We said the number of moles of nitrogen is 1.79. So I get the number of moles of ammonia. The equation says, did you see the equation? The equation says that the number of moles of ammonia is twice the number of moles of nitrogen. So I multiply that, I get 3.58, and that from that I can get the mass. We said mass is number of moles times mR, and that means that I should get 60.9 grams of ammonia. Do we understand the idea? So let's go back again, just a step. If he gives me the number of moles of both reactants, I get, if he gives information about both reactants, I get the number of moles of both reactants. And then I determine which one is too much and which one is not too much. The one that is too much, we call it excess, and we don't use it for anything anymore. The one that is not too much, we call it limiting, and this is the one that we use to relate to whatever he's trying to get. Okay? Okay, so that is the end of this chapter. Please study it, try the chapterized questions, and we'll then see the answers to these questions.